Hello everyone, my name is Akira Yoshi and I will be delivering a presentation which focuses on the application of deep learning models in solving a prediction problem. A quick outline of what we'll go through today. First of all, we'll specify the problem and the source of the data. We will then briefly explore the data. Next, we will define the baseline model and discuss how we will handle time series data. We will then fit the two deep learning architectures and finally compare the models. The problem that we will be investigating is predicting the Japan population mortality rates. Mortality rate prediction is a common regression problem which has applications in the field of characterizing populations, developing pension and social security schemes, setting life insurance premiums, healthcare applications, and more. This problem will be based on the Japan population data sourced from the Human Mortality Database. It contains age-specific mortality rates across the time period of 1947 to 2020 for females, males, and the overall population. For the purpose of this investigation, only the ages from 0 to 99 are considered as the data in this range is complete. Scatter plots of the female and male data is presented, and it can be seen that the mortality rate for both genders follows a similar age trend. We define a baseline model, which will be used as a comparison benchmark for evaluating the deep learning models. Since we're investigating a regression problem, the mean squared error will be used as the comparison metric. The baseline model is a fairly simple model which is set using the prediction rule that next year's mortality rate will equal this year's mortality rate. Since we are looking at time series data, it is split without shuffling using the following time periods. In order to follow a workflow structure, the models will be fitted using the training data, evaluated on the validation data, where the computed validation loss will determine the best performing model, which will then be used in the test data. For the model fittings, we will use a range of look-back periods to predict the mortality rate 1 year ahead. The first deep learning method we will use is the long short-term memory architecture, which is a type of recurrent neural network suitable for modeling time series data. In particular, this model contains two hidden LSTM layers with 128 neurons each and a ReLU activation function. It also contains two dropout layers in between, which reduces overfitting. Here, a summary of the parameters is shown, as well as a plot of the model to better visualize the structure of the architecture. The second deep learning method we will use is the convolutional neural network architecture. Typically, CNNs are used for classification problems. However, it can still be used for time series forecasting using slightly different hyperparameters. This CNN design in particular contains convolutional layers with filters, pooling layers, a flattening layer, and the fully connected neural layers. Early stopping was also used when fitting both models to prevent overfitting. Again, a summary of the parameters and a plot of the model is shown. As a form of hyperparameter tuning, a range of lookback periods were tested. It can be seen that using a smaller time series improves the predictive performance of both models. Comparing the optimal models from the previous slide, it can be seen that the validation loss across both models are very similar, and were unable to outperform the benchmark. However, with further hyperparameter tuning of different features of each architecture, these results can be improved.